There's a number that every missile defense system in the world shares, a number that engineers calculate, that commanders monitor obsessively during combat, and that entire governments try desperately to keep classified from their adversaries and from their own citizens alike. That number is not the interception rate, it is not the accuracy percentage, it is not the speed of the interceptor or the range of the radar. The number that matters more than all of those combined is the simplest and most brutal number in all of modern warfare. How many interceptors are left in the magazine? Because a missile defense system with a 99% success rate and 0 remaining interceptors does not have a 99% success rate anymore. It has a 0% success rate. It is an empty launcher pointed at the sky, surrounded by billions of dollars worth of radar equipment and fire control computers that can see everything coming and do absolutely nothing to stop it. According to reports that have emerged from this conflict, that is precisely the threshold that was crossed over Tel Aviv on a single night, when 23 Iranian strikes reportedly reached targets inside the city. Not because Israel's defense technology failed, not because the interceptors malfunctioned, not because the operators made errors under pressure, but because after days and weeks of sustained Iranian bombardment designed with mathematical precision to produce exactly this outcome, the interceptor supply reached a point where the rate of consumption exceeded the rate of replenishment, and the system that millions of Israeli civilians had been told would protect them simply had nothing left to fire when it mattered most. If that report reflects what actually happened, and we are going to be very careful throughout this video about distinguishing between what is confirmed and what is claimed, then what occurred over Tel Aviv that night was not a military failure in any conventional sense. It was the inevitable arrival of an arithmetic reality that defense analysts have been warning about for years, a reality that this channel has covered in detail across multiple previous videos, and a reality that carries consequences not just for Israel, but for every nation on Earth that depends on missile defense to protect its population, including the United States of America. If that does not stop you in your tracks and make you want to understand exactly how this works, exactly why it was predictable, and exactly what it means for what comes next, then I do not know what will. But if it does, and I suspect it does because you are watching this channel for a reason, then hit subscribe for War and Wealth right now and tap that notification bell, because what we are about to walk through in this video builds directly on the analysis we have been developing across this entire series. And by the time we are finished today, you're going to understand a dimension of modern warfare that most people, including most people in positions of political authority, have not yet fully grasped. Let us get into it. I want to start exactly where I always start, which is with complete honesty about what we know and what we do not know. Because that honesty is the foundation that everything on this channel is built on, and I will never compromise it. As of the time this analysis is being produced, the claim that 23 Iranian strikes reached targets inside Tel Aviv in a single night originates from reporting that includes Iranian state media, regional outlets, and open-source intelligence analysts tracking the conflict in real time. The specific assertion that these strikes succeeded because Israel's interceptor stockpiles were depleted to the point of inability to mount a comprehensive defense has been discussed by multiple credible defense analysts, though the precise details of Israel's remaining interceptor inventory are among the most tightly guarded secrets in the Israeli defense establishment and have not been independently confirmed through any publicly available source I would consider definitive. Israel maintains strict censorship over information related to the specific performance and capacity of its air defense systems during active hostilities, which is a well-documented and long-standing practice rooted in legitimate operational security concerns. What I can do, and what I am going to spend the rest of this video doing, is walk you through the verified, documented, independently confirmable facts about how interceptor depletion works, why it was mathematically inevitable given the parameters of this conflict, what its consequences are for both the military and civilian dimensions of the war, and why this principle applies with equal force to the defense of American cities and American military installations if the United States ever faces a sustained missile and drone campaign from a determined adversary. Every element of that analysis is grounded in published data, confirmed system specifications, documented production rates, and strategic principles that are not disputed by any serious defense professional. To understand why running out of interceptors is not a surprise outcome, but a predictable mathematical certainty in any sustained conflict against a determined adversary, you need to understand 4 numbers that define the fundamental equation of missile defense economics. The first number is the cost of an individual interceptor. Israel's Iron Dome system, the layer of defense responsible for engaging the short-range rockets, cruise missiles, and drones that constitute the majority of threats against populated areas, uses the Tamar interceptor missile manufactured by Rafael Advanced Defense Systems. The cost of a single Tamar interceptor has been publicly cited by Israeli defense officials and confirmed by multiple credible defense publications at approximately $40,000 to $50,000 per round. That is the cheapest interceptor in Israel's multi-layered system. David's Sling, the medium-tier system designed to engage larger rockets, cruise missiles, and short-range ballistic missiles, uses the Stunner interceptor, which costs approximately $1 million per round. Now, the Arrow system, Israel's upper-tier defense against long-range ballistic missiles, fires interceptors that cost several $1 million each. These are not contested figures. They are documented, confirmed, and publicly available. The second number is the size of the interceptor stockpile. This is the number that Israel guards most jealously, and for very good reason. Because if your adversary knows exactly how many interceptors you possess, they know exactly how many offensive weapons they need to launch to exhaust your supply. Precise inventory figures are classified, but credible estimates from defense analysts who study Israeli procurement budgets, production contracts, and delivery schedules have placed the total Israeli Tamir interceptor inventory at various points during the conflict in the range of several thousand rounds. A number that sounds large in isolation, but becomes far less comfortable when measured against the rate of consumption during sustained high-intensity bombardment. Production capacity for replacement TAMRs, even with emergency surge manufacturing underway at Rafael's facilities with American financial support authorized through supplemental defense aid packages, is measured in hundreds of interceptors per month, not thousands. The gap between consumption rate during active defense and production rate during emergency manufacturing is the gap through which depletion occurs. And it is a gap that no amount of money can close instantaneously because manufacturing precision-guided interceptor missiles requires specialized facilities, trained personnel, quality-controlled components, and testing protocols that cannot be accelerated beyond certain physical and industrial limits regardless of how much funding is available. The third number is the cost of the offensive weapons being used to force that consumption. And this is where the mathematics become genuinely devastating for the defender. A Shahed-type drone, the kind Iran has produced in large quantities and employed extensively both directly and through its network of allied groups, costs somewhere between $20,000 and $50,000 to manufacture. A basic artillery rocket of the type, produced in large quantities by groups operating from Lebanon and Gaza, costs a few hundred to a few $1,000s. Even Iran's more capable ballistic missiles, while significantly more expensive at estimated costs of several $100,000 to a few $1 million per unit, are substantially cheaper than the upper-tier interceptors required to defeat them. The attacker's cost per offensive round is, across virtually every category of weapon being employed, a fraction of the defender's cost per defensive round. This means that every exchange, every wave of attack and defense transfers wealth from the defender to the attacker in a ratio that compounds over time. The defender is spending more per engagement than the attacker, and the defender's industrial base cannot produce replacements as fast as the attacker's industrial base can produce new threats. The fourth number, and this is the one that ultimately determines when the system crosses the depletion threshold, is time. Not time measured in minutes during a single engagement, but time measured in days and weeks across a sustained campaign. A single night of heavy bombardment might consume hundreds of interceptors. A week of sustained engagement across multiple threat axes simultaneously might consume 1,000 or more. And the key insight, the insight that transforms this from a manageable logistics challenge into an existential military problem, is that the attacker gets to choose the tempo. The attacker decides how many waves to launch per day, how many days to sustain the campaign, and how to distribute those waves across time to maximize the consumption rate while minimizing the defender's opportunity to resupply. A smart attacker does not launch everything at once in a single dramatic salvo that the defender can concentrate all resources against. A smart attacker launches enough in each wave to force the defender to fire interceptors, spaces the waves closely enough that the defender cannot meaningfully resupply between them, mixes cheap drones with more expensive missiles to force the defender to engage across multiple cost tiers simultaneously, and maintains this pattern day after day until the arithmetic does what the arithmetic was always going to do. This is not a revolutionary tactical concept. It is basic attrition warfare applied to the domain of air defense, and it has been described in open-source military literature, war game analyses, and professional defense journals for years. The only thing that is new is that we are now watching it happen in real time against one of the most sophisticated and most expensive air defense architectures ever constructed. The reported outcome over Tel Aviv, if accurate, represents the moment when the consumption curve crossed the supply curve. When the cumulative expenditure of interceptors over days and weeks of sustained Iranian bombardment finally exceeded the combined total of pre-war stockpiles and emergency wartime production. And the consequences of crossing that threshold extend far beyond the immediate military domain into the political, psychological, and strategic dimensions of the conflict in ways that are genuinely difficult to overstate. Because missile defense in a country like Israel is not merely a military system, it is a social contract. It is the foundational promise that the government makes to its citizens, the promise that says yes, We live in a dangerous region. Yes, we face adversaries who want to harm us. But we have built a shield that will protect you, that will keep your children safe, that will allow you to continue living your lives with a degree of normalcy even during times of conflict. Iron Dome in particular has occupied a unique place in Israeli national consciousness since its first operational deployment. It has been celebrated in Israeli media, cited by Israeli politicians as proof of the nation's technological superiority, and experienced directly by millions of Israeli civilians who have watched its interceptors streak across the sky and felt the reassurance of knowing that the system was working, that the explosions they heard were interceptions rather than impacts. When that system reaches a point where it can no longer provide comprehensive coverage, when strikes begin reaching the city, not because the technology failed, but because there are simply no more interceptors available to fire, the psychological impact on the civilian population is not proportional to the number of strikes that get through. It is catastrophic and disproportionate because it destroys not just buildings, but the foundational sense of security that allows a society to function under threat. The political consequences for Israel's government flow directly from this psychological rupture. A government that has built its legitimacy partly on the promise of security, that has justified the costs of war partly by pointing to the effectiveness of its defensive systems, faces an entirely different domestic political environment when those systems visibly fail to protect the country's largest population center. The questions that emerge in that environment are not gentle or patient. They are urgent and angry. Why were stockpiles not larger? Why was production capacity not expanded earlier? Why were diplomatic alternatives not pursued more aggressively when it became clear that the attrition math was trending toward depletion? These questions do not wait for the war to end before they demand answers. They emerge in real time, amplified by social media, by footage of unintercepted strikes hitting residential areas, by the visible fear on the faces of civilians who no longer trust the system to protect them. And those questions create political pressure that constrains the government's strategic options in ways that the adversary understands and deliberately exploits. A government facing a domestic crisis of confidence in its basic protective capability is a government that may be forced to accept ceasefire terms it would never have considered while the shield was still holding. The depletion of interceptors does not just change the military balance. It changes the political balance in ways that can determine the outcome of the war more decisively than any battlefield engagement. The relevance of this analysis to the United States is direct, immediate, and profoundly uncomfortable for anyone willing to think it through honestly. The United States military depends on the same fundamental missile defense principles, the same finite interceptor inventories, and the same cost-asymmetric dynamics that have produced the situation we are analyzing in Israel. American Patriot batteries carry a specific number of interceptors per launcher. American Aegis destroyers carry a specific number of SM-2, SM-3, and SM-6 missiles in their vertical launch cells. American THAAD batteries carry 48 interceptors each. None of these systems have unlimited ammunition. All of them face the same mathematical vulnerability to sustained attrition that we are watching play out in Israel right now. And the American industrial base, despite being far larger and more capable than Israel's, faces its own production rate constraints for precision-guided interceptor missiles that cannot be overcome instantly regardless of funding levels. The time required to manufacture a single SM-3 Block 2IA interceptor, from raw materials to completed, tested, deliverable round, is measured in years, not weeks. The number of facilities capable of producing these weapons is limited. The supply chains that provide specialized components, from guidance electronics to solid rocket motor propellant, are complex, globally distributed, and in some cases dependent on single-source suppliers whose capacity cannot be doubled overnight by writing a larger check. Multiple senior defense officials have publicly testified before Congress about the need to expand the American industrial base for precision munitions and interceptor missiles, citing the lessons of ongoing conflicts as evidence that current production rates are insufficient to sustain a high-intensity conflict against a peer or near-peer adversary. The fiscal year defense budgets submitted in recent years have included significant increases in funding for munitions production. And the Pentagon has entered into multi-year procurement contracts designed to provide manufacturers with the demand certainty needed to justify facility expansion. But industrial capacity expansion is a process that takes years to implement. New production lines must be designed, built, staffed, and certified. Worker training pipelines must be established. Supply chain bottlenecks must be identified and resolved. And throughout this entire expansion process, the existing inventory continues to be drawn down by current operational commitments, training requirements, and the ongoing need to maintain ready stockpiles across multiple theaters simultaneously. The gap between where the American interceptor industrial base is today and where it needs to be to sustain a prolonged high-intensity conflict is real, documented, and acknowledged at the highest levels of defense leadership. The The question is whether that gap can be closed before it is tested. The directed energy solution that I have discussed in previous videos on this channel remains the most promising long-term answer to the interceptor depletion problem, because a laser weapon powered by a generator and an electrical supply theoretically eliminates the magazine depth constraint entirely. You do not run out of laser shots the way you run out of missiles. As long as the power supply is functioning, the system can continue engaging targets indefinitely at a marginal cost per shot measured in dollars rather than thousands or millions of dollars. Israel's Iron Beam laser defense system and various American directed energy programs represent genuine technological progress toward this capability. But genuine technological progress and deployable, reliable, scaled operational capability are two very different things. And the timeline for transitioning from promising demonstrations to combat-ready systems fielded in sufficient numbers to meaningfully change the interceptor depletion equation is still measured in years. Weather sensitivity, atmospheric attenuation, power generation requirements, thermal management challenges, and the fundamental physics of directing sufficient energy onto a fast-moving target at operationally relevant ranges all remain active engineering problems that have not yet been fully solved for all-weather, all-condition operational deployment. Until they are, the interceptor missile remains the primary instrument of active air defense, and the interceptor missile remains a finite, depletable, expensive, slow-to-replace resource that can be systematically exhausted by a patient adversary willing to trade cheap